Yeah, so I put some thoughts down based on our earlier conversations and emails and stuff, and we can, and I think Scott, you wrote down some thoughts as well. But I think there's really three somewhat different discussions, and they're very interrelated, but I think we can split them out a little bit. One is what should the NuPIC API be? Right. Then there's a question of languages, which I think is fairly straightforward. And then the third one, which is probably the most debatable, is the repository and code structure and stuff like that.
Right.
But I think that's independent of this discussion of what should the NuPIC API be.
Yeah. So let's leave the repository discussion out and just talk about the API surface area, where the language binding should be. Those two things. So
you don't want to talk about that, or
not really? It shouldn't affect how we cut up our API, right? The API should define itself, no matter how the repository is broken up.
Okay. So do you want me to describe the, so we have algorithms, we have the network API, and then we have the OPF.
Right.
And those are the three big chunks of code that we have. And my proposal is that the network API and region API, that should be the NuPIC API. Right, that's the proposal. And actually hasn't changed in a couple of years and is very generic. And you can imagine, are you still there?
Yeah, I'm here. I'm just looking at the code here.
Okay. It's very generic. It can, it's independent of the algorithm. You can make lots of iterations on the algorithm, and the API shouldn't have to change. It can support lots and lots of different types of applications. It's not specific to a particular type of application. We've in the past thought through a lot of stuff that any NuPIC or any CLA network would need to have, and it includes a lot of that stuff. And it supports vision and OPF and language stuff, and you can support hierarchies and all sorts of things.
All right.
So I think that it would be really hard not to include the network and regions stuff. I'm pretty sure you agree with that. That's not really an option.
Yeah, and I'm saying that's it.
Okay.
I'm saying that is the API.
So
no more than that.
Let's talk about what would be the closest things that we might want to include in addition to that, since that's currently kind of our lower limit.
Yeah. So the next logical thing is you can say the algorithms, include the interface to the spatial pooler and the temporal pooler as part of the API.
So you're saying not even include the algorithm?
No. The network stuff is independent of algorithms.
So it doesn't do anything.
I know. I mean, no API. It's just sort of defining the interface. It doesn't actually. It does do stuff. We can walk through what it does, but it's generic. It's not specific to the algorithm.
So the NuPIC product could define an API that includes the network API as well as which defines a contract between it and whatever algorithms are going to interact with it. So,
correct.
I mean, NuPIC could include the network API as well as a set of prepackaged algorithms that work with it.
Yes, but the details of the algorithm, I imagine, like when we do sensory motor stuff, it could be very different from what we have now. Or, Fergal wants to change the algorithm in a certain way to handle the fact that all cells in a column are not the same. And so there's experimentation we want to do. And someone might say, you know what, we don't want a separate spatial pooler and temporal pooler. We should have it all together doing the same thing. That's totally reasonable to do that. With all those experimentation things are independent of the API, I think.
And we want to do this in a way so we can package up the algorithms we think are important and core for the CLA that should be within NuPIC, as well as allow extensibility.
Yeah, so that gets to the repository discussion.
Right.
What we include, but yeah, the proposal would be there'd be a basic CLA implementation, spatial pooler and temporal pooler. That's a reference implementation of the current set of algorithms. But those are not frozen in stone.
Okay. The current set of algorithms are not.
Yeah.
But the
So
API
that's
between the
online.
algorithms and the network API is flexible enough to allow a lot of expansion.
Right. So that's one line in the sand. You could reasonably argue, okay, let's put in the spatial pooler and temporal pooler as well as part of the API. Everyone's going to use that anyway, initially, and then if you change that, well, that's just a change in the API. So that's the other argument.
Yeah. So just to be clear, when you say, let's say we only do the network region as the API.
Yeah.
Does that mean that that's sort of separate for whether or not we include the CLA algorithm in the repository?
That's just, yeah. Although I think we would, but yeah, we want to, but yeah.
We would
that's
want
a separate,
to include them?
That's a separate discussion of what is the API.
Got it. Okay, now I understand better. Okay. Now, one thing with the network region API, as it is now, it's not totally flexible in that you have to specify like things that you can pass through the regions. Have to be sort of specify the type and everything.
Yeah.
And I think you're limited in what types you can use. I think you've limited basic types.
Yeah.
So if you wanted to use that framework for, I don't know, can you do vectors?
Yeah, you can do vectors. I think.
Okay, then that should be generic enough.
It's pretty generic. You mean vectors, STL vectors?
Yes.
I don't think you can do generic STL vectors. You can do a numerical vector.
You can do an array.
You can do an array.
Is that what you mean by numerical vector?
Yeah. It's not a data type, it's just conceptually an array of numbers.
Okay.
That's what.
Yeah, but in our implementation,
the
actual data types that you can specify as things you can pass through, can you specify STL vector or only?
I'm not sure. I know you can do numbers. I remember there was a discussion about whether you can pass strings back and forth, or arbitrary data types. And we could you could imagine expanding the API, the quote-unquote API, to include those things over time.
Are you talking about between regions?
Between regions, yeah.
And when you're talking about vectors right now, vectors of what?
Just real valued numbers.
Yeah, just scalars. It's basic primitive types, but.
And part of the reason for that was also you have to really think about serialization, and everything in the network, in the regions in C++ is implemented as contiguous memory buffers.
Mm-hmm.
So it's extremely efficient. There's no copying going on. And it's also helpful when you think about parallelizing and going across processes and across servers, that there be a very basic representation that you can send very efficiently. So those are some of the considerations in that. But you could, I suppose, add other types and say, okay, it could be any STL vectors, but you have to have a serialized method or something and a deserialized. So I'm not familiar enough with the details to know if it actually handles other types yet or not.
Okay. So we can I would assume there's already a contract between the network API and the existing algorithm, so those just need to be documented and published, right?
Yeah. So the way the network API works is there's a concept of a region and a network and linking between regions. So a network is a container for everything. And then it's made up of regions that are linked together, and the linking can be, arbitrary. Link regions up as you want them, and then a region is what implements what's actually doing the work. And so we have a CLA region that implements, I think, both a spatial pooler and a temporal pooler. We have a classifier region. We have sensory input regions. And so you can just hook them all up.
And our current CLA model class has a network inside of it.
Yeah.
That it creates that has a CLA region inside of it.
Right. So that's the OPF.
Yeah.
The CLA model is part of the OPF, and it's on top of the network. So it uses the network API to construct the thing and run it.
Is the CLA model part of the OPF or the
The file CLA model.py is part of the OPF, and it creates a network with CLA implementation regions inside it.
So then, when we get into the Python algorithms, where does the line break between the OPF and the Python algorithms?
The algorithms are not part of the OPF.
Right, but they use the algorithms, right? The OPF does.
The OPF uses the algorithm, yeah. So if you, it might be easier if I draw it. So.
Well, the OPF doesn't really use the algorithms. There's an OPF model called the CLA model that I guess is part of the OPF, and that uses the algorithms inside of the network.
Okay, so the algorithms have an interface as well. That are used from the outside, right? I mean, one thing I don't quite understand is if I were to like rebuild the OPF, because I don't really understand how that works. If I were to make my own and try and use the network API directly with some set of algorithms, would I be interfacing with the algorithms and the network API, or the network API and telling it what algorithms to use? What's the approach there?
You would use the network API and tell it which regions to use. So you would say, let's say you wanted to take a vision image input, send it to 2 levels of a CLA, and then some other classifier.
Mm-hmm.
Okay. So what you would do is you would create an image sensor region. You would create 2 instances of the CLA region. You would create an instance of your top-level classifier region, and then you would tell it how to link those 2 together, all of those together.
So the classifier is also part of the Python algorithm set?
Well, don't worry about Python.
I mean, is that algorithm specific?
This is just sort of conceptually, a region is a container for something.
Right, but even if we're not talking about Python, we're just splitting between network API and algorithms. Where is the classifier?
The classifier is another region that we've implemented.
Also, the spatial pooler, temporal pooler, classifier are implemented as classes that you can use standalone, not part of the network's regions. And then there's a region wrapper around each of those. So there's an SP region, a TP region, and a classifier region that just basically are an interface between the network and region API. They implement the region interface, and then they interface down to the whatever algorithm class.
Okay.
Okay, so let me try. I don't know if you can see the
Not yet.
board at all. Can you see what I'm writing?
I don't see anything on the board yet. No, that's pretty good. Yeah.
Here, can you? Oh, that's too.
No.
Okay.
There we go.
Okay, so here's the network API with an underline.
Yes.
Okay, so this defines regions. There's a region interface. There's a network interface.
And that's just a container for regions.
It's a container for regions. And there's a linking interface. Link interface. Okay, so a network is a container for regions, and I think it also contains all the links. And so you could set up, for example, a network like this. So let's say this has audio sensors, this has image sensors. This is a CLA. This is a CLA region. Here's another CLA region. These are all kind of feeding in this way. And then there's some classifier here.
Okay.
Okay, so this would be like a hierarchy that you might build up.
Right. And
this would be the neocortex with 3 different 2 levels and 3 regions.
Mm-hmm.
And the input is coming from the image or an audio, and then you have a classifier. So you might want to create a network like that.
So if the boxes with the CLAs in them from the network API standpoint, those are just black boxes, right? We could put
those are just black boxes, They have to implement the region interface.
Right, they have to implement the region interface. So I assume there's some standard of passing information in and out that's defined in the network API.
Exactly. So each region has inputs and outputs. Some number of inputs and some number of outputs. The region has parameters that you can set and get, and regions serialize themselves and deserialize themselves. So there's an interface for that.
Okay.
There's an interface for running it. So there's a call to do one step of compute, one compute call. So at the end of it, once you have this, once you set it up, all you have to do is, again, this is conceptually for R in my regions. Actually, I think you just call run. Yeah, I think you can just, if you have a network, at the end of it, you can just call network.run, and you define an order, compute order here, by the way you link and it'll just call compute continuously. So it's very simple, but it's got all the basics of serialization, setting parameters, linking things up, specifying these memory buffers and all that. It's very raw, but it's very conceptually very simple.
Now, I don't think this is really necessary, but the CLA black box happens to also create a network inside itself as well, right?
No. Shouldn't. Okay. Yeah. So this is all C++, no Python yet.
Right.
This is the model. Everything is in C++. You can do the full thing in pure C++ if we had C++ implementations of all these regions.
Right.
To handle Python, what we've done is we created something called a Pi region. Which matches the region interface, and this thing takes the name of a Python file.
Yeah.
And it loads it in and uses C++ to call the Python file.
Oh, so that's your language binding.
That's a language binding. So it's just a C++. It's just another C++ region.
Okay.
Right? So it assumes that the Python file is going to match the region interface.
Okay.
Just to clarify,
so that way you can write regions in Python because we happen to have a C++ Pi region.
Okay. To clarify, Matt, when you say language binding, generally when I talk about language bindings, I'm talking about the other way, where we basically allow you to call the C++ from another language. Mm-hmm. This is going the other direction and letting the C++ call back to the language.
Yeah.
Right, and this is how we have to do it if we want to allow anybody to write their algorithms for one of these region black boxes in anything other than C++.
Yes, they need the ability for C++ to call it.
Right.
So you could have a Java region, for example, and as long as there's a way to call it, you could do that. You could have JavaScript region. You could do whatever you want.
Right.
There. The other thing is what a region is again, all it has to do is form the region interface. So people have wanted to, for example, have CLA networks that are spread across servers.
Uh-huh.
So one way to do that is to have TCP region. All it does is, instead of calling into Python or an algorithm, it calls to another server.
Right.
And it can have parameters in here that tell it which server to connect to and stuff like that. And so just if someone were to implement that, now all of a sudden you can spread these networks across servers.
So this isn't a huge extensibility point, just being able to take a region and turn it into whatever type of interface to any other environment that you want it.
Exactly.
Okay.
Yeah.
Cool.
And one of the things I like about it is, one, it's very simple. Two, it's very, very lightweight. There's almost nothing in here, other than a contract.
Right.
And it is designed to be extremely efficient. So input-output buffers are memory buffers that are static. They don't change once they're set up. So you could actually implement very, very fast algorithms and very fast communication mechanisms and stuff like that.
So this is probably going to step back another step, but we talk a lot about encoders, and are encoders entirely having to do with OPF? That those are out of this scope, right?
Yeah. So the way the OPF implements encoders is there's something called I think it's called a sensor region. It is one of these pi regions that I mentioned.
Mm-hmm.
So it's I think this is correct. So it's a sensor region, and inside the sensor region you can have any number of encoders. So you can have encoder 1, encoder 2, and so on.
So I can use encoders as to hook up my my input without using the OPF because of the sensor region.
Correct.
Is sensor region a part of the OPF, or?
I've been thinking it is, but it doesn't have to be. I imagine. I guess you could imagine using these encoders in non-OPF scenarios.
I mean, in the end, the OPF is really just it's a sort of an example of how to use this whole structure, and the one we've chosen to implement on top of.
Correct. Yeah, and it may be that it may be totally reasonable to use encoders for something completely different, some other CLA application. So
I'm just envisioning a long list of.
Earlier.
Sorry, I was just thinking there could be a long list of potential regions here.
Yes.
Different kinds.
Yes.
And that's something that the community could create.
Exactly.
Who knows what they could hook it up to?
Exactly.
Okay. Okay.
So most of what we have done is in the form of pi regions. And that's just because it's really fast to implement these things. But over time we could do more and more of these regions fully in C++.
Right. I mean, this really seems like everything is in place. We just need documentation and examples of how to use each one of these components specifically. Even a tutorial of how to build your own region.
And I would say, even a good chunk of the documentation is there.
Right.
I sent the link to the wiki page. This is something we had put in there a while ago.
Uh-huh.
I think we do even have more detailed documentation we could throw in there as well. So I would say this is fairly reasonably documented.
Okay.
This is actually getting back to the original NuPIC releases that from the old algorithms, because this used to be something that we distributed to external developers.
Yeah.
Right?
This is in the current NuPIC. It's a much simplified version of what we used to have.
Okay.
So this is.
It's not a separate implementation though.
It is separate.
It's an applet. No.
This is technically NuPIC 2.
Okay.
So we completely threw away NuPIC 1, which had I didn't explain why, but it was very complicated.
Okay. So
this
this
is
stuff
much
was never
simpler.
released.
This stuff until we did our NuPIC release, it's never been publicly released yet until this year.
Okay.
But I'd say it's documented. I don't think there are good examples yet. But the good thing is it's there. It's very lightweight. It's documented, and there's a reasonable set of unit tests, and test coverage of it.
Right. But the one major thing that's missing, unless I missed it, is like real API docs around each class and method and every public-facing part of this interface.
I'm not sure about that. I think it is documented in the code and places. We may not have a way to extract it automatically.
Right.
I remember there used to be some like documenter thingy, but I don't remember.
Yeah, there's some stuff. And it was also there was a class that would basically take it when it was built with Swig and extract the documentation from the C++ and insert it into the Swig Python classes so that you could get the doc strings from Python, but that is not in there currently. But it's pretty well documented, that core C++ stuff.
In the code.
Yeah, so let's say what's there is that the implementation is there.
That's good.
It's, architecture docs are there. API docs, we think are mostly there, but potentially someone could improve that. So this is a question mark, and tests.
Okay.
And I'm not going to claim it's comprehensive tests, but there's a reasonable set of tests there.
Right.
What's missing? The biggest thing that's missing is probably the most important thing: is a full C++ CLA region.
Ah.
Okay, so what we have is a C++ implementation of the spatial pooler, and 80% of the temporal pooler in C++, but someone needs to take all that and create an actual C++ CLA region. Without that, this thing is useless from C++.
Right.
So that's probably the biggest thing that's missing. And then good examples, and better docs.
Yeah, I would say published API docs, not just in the code.
Yeah.
I've been looking a lot at like the Android docs, and they've got one that's obviously generated from the code base that's really rich, and then there's just a series of tutorials that's constantly referencing that. Something like that would be great.
And then what you mentioned before is just more regions to make it more useful.
Now, even without the C++ CLA region, we could still harden this API. I mean, we could still dock it and say this is it. And we would still be backwards compatible once we got to creating that C++ CLA region.
Yeah.
So we could do this entirely just. So I'm just thinking about who's going to work on this as we move forward, and this is all the stuff that needs to get done aside from the CLA C++ region is something that I could do without intimate knowledge of how it works.
Yeah, and you could even put in place a lot of the examples as well, because there are Python bindings for everything. We even have Python bindings for our Python bindings, and you can actually. I could show you. There's test code where we create these networks and regions from Python, and it looks identical to what you would do in C++, almost identical.
Oh.
And so you could create a draft in Python of what might be good examples, and someone could convert them to C++.
Okay. Okay, so this is great. This is simpler than I thought it would be. So.
Yeah, and it's very easy to make this super complicated, and we did this with NuPIC 1.
Yeah.
We went really wild with this thing, and it was okay, it worked, but it was actually very hard to make this interface very simple and clean.
Right.
And I think the current one is very simple. It's almost like too simple.
Right.
But I'd rather start with too simple and then.
So I think the way forward that I'd like to go is try and create these published documentation of these C++ network API. And I know it's it's very very small, but it looks like these interfaces are very important, and we could probably create documentation along with those with examples of usage of it. And then aside from that, how to create your own set of algorithms to work with the network API.
Yeah. Yeah. So there's having good API docs would be great as a first step, and maybe along with that a set of examples on showing how to create create a network like this and run it.
Right.
We actually have dummy regions that do nothing, so you could use those to create networks like that.
Right.
And just show how it works. Someone could do that right away.
I think that would be the best thing to do, just because it exposes it and it doesn't require people to go diving into the code and trace their way through it. So I think that's not the most important thing at this point, to continue having this discussion. And it might expose some things that we didn't think about, or that someone points out, maybe we should do this different, but when we do finally kind of solidify this, there's no going back. So getting what we have right now as exposed as possible and as clear and detailed as possible so that anyone can look at it's important.
Makes sense.
Okay. So I guess that's the way forward.
Okay. Do you also want to talk about repositories or no?
I kind of. I don't. The thing is, I don't want to get ahead of ourselves and think about how to break up the code until we've defined it.
Okay.
Maybe we can kind of theoretically talk about what we could do, and we could do that. I mean, obviously, we want to have the network API that it's one cohesive unit and it has one job, and that's a good repo, right? So if we want to theorize about other repositories, so I'm thinking about extensibility. So I like the idea of having repositories for like pluggable components, like the algorithms, like the regions, or at least something like that. But I don't know if that makes sense. I'm just kind of brainstorming. But we don't want people coming in and messing with the network API. That should be sort of the core of it. But what are people going to want to do? They're going to want to make regions, and they might want to make comparison algorithms, and they may want to toy around with prototypal sets of algorithms, and maybe it's useful to some people, and we decide we should publish it along with our algorithms as well. If it's well documented and it gives an example of how to do something. I mean, I think that's great. So I kind of like having that separation of these pluggable components that can be used with the network API, but then you also have to have something that actually runs the program that ties all of it together. And I don't know what the best answer is for that.
Yeah, I like that, and again, the stuff that Fergal is proposing is a great example of, maybe the most complex version of it.
Yeah.
Changing.
And having the ability to run those in parallel, even within the same code base, is really nice.
Yeah, and in fact, we do that today. We have several implementations of the spatial pooler now, and we can run those. So.
Now, as far as the OPF, I really still kind of feel like the OPF is it obviously is a client to the network API.
Right.
It puts together the pieces appropriately and uses the network API to create an interface for the end user that's friendlier for a specific use case.
Yeah, it's a very specific targeted use case.
Right. So yeah, I do kind of think that's another
30 very specific. It's 30 very specific targeted use cases all orged together in the code.
Right.
It's pretty messy.
But it's a certain type of client for this, and there could be other types of clients that do entirely different things, but are useful to keep in kind of this suite of satellite projects around NuPIC core that uses NuPIC in different ways with different input data.
Right.
I don't know if online prediction framework. I guess that's a good initial term for it, but
Yeah, and I think you and Scott have convinced me. I mean, initially I was thinking the encoders are just a part of the OPF, but maybe that's a piece to split out and, make more clean, and that's something people could reuse elsewhere.
Yeah.
That kind of reduces the OPF footprint, if you will, a little bit.
I don't know. I still, if there's things that are going to be very commonly used with the NuPIC core,
yeah.
I think in the repo, whether it's part of the API or not, in that repo, you should be able to, with that, run something useful. The network and region code by itself without encoders, or with the algorithms without encoders, isn't necessarily that. Maybe some people, I think it's going to be a small percentage of the cases that's useful by itself.
Mm-hmm.
So that's why I think we should include the encoders. And then also, sounds like everyone's leaning away from including the OPF, but which I kind of agree with. But the one thing about it is, I wouldn't say that's specific to a small percentage of uses of it. I think it's a very large percentage of uses of it, because very commonly you're going to want to swarm.
Yeah, anything where you have streaming data, it's numerical and so on, you'd want to. OPF is a good place to start. Swarming right now is pretty specific to the streaming data. Conceptually, it's not, but the code is.
Yeah, it is specific to streaming data. Yes.
But someone else could. That's another project actually. If once we define this API, you could imagine doing swarming at the level of networks, and not at the level of the OPF. So take that algorithm. Anyone who creates a network can now use the swarming algorithm because there's a predefined interface to it. That'd be kind of nice.
Yeah.
Yeah. Today the swarming is in there, and even encoders, the implementation is kind of specific to the way the OPF wires up networks and its interaction with the classifier and stuff like that. But it'd be nice to pull it out so it's not so specific.
Yeah.
The other thing is OPF is all in Python, 100% Python.
Right. Okay. And one other thing about the repo discussion, and maybe I don't think it matters a whole lot at this point. Hi, Scott. Nice to see you. Because whether it's all one huge repo or a bunch of small repos, I mean, in the end, it's going to work the same. And the reasons that we break it out into a bunch of repositories isn't necessarily because we need it to work any differently. So that's why I don't think it affects what the API is going to be, or shouldn't affect what the API is going to be, or how it's used. It really just should affect how it's built and deployed, right? Okay.
Yep. Sure.
Okay, so I won't be able to work on this for a couple weeks, and I know, Scott, you're busy, but the first thing I want to try and do when I come back is get some automatic docking working on the network interface. So that'll be the first thing I try. I'd love to get some. I've got some experience making API documentation, so I like doing that sort of thing. So I don't mind taking that and running with it. So that's my plan.
Okay.
And then we'll see. So then I'll show you guys, and we'll continue the discussion and take it from there.